So now we're going to go through some specific arrangements. So arrangements in a circle. So most commonly this will be in a round table, and later on we'll explore what happens when you have a necklace or bracelet. So arrangements in a circle is going to be slightly different from arrangements in a straight line, and I'll show you why. So for example here, if we have some 5 people in a straight line, so 1, 2, 3, 4, 5, that's going to be very different from when we have that arrangement, which is 5, 1, 2, 3, 4. Yeah? Can you see how they are very different from each other? But when you have them arranged in a circle, so I join the 5 and 1 together, and here I join the 4 and 5 together, can you see how the circles are actually exactly the same? But this circle is just tilted a little bit, so that 1 goes here, but the people are still seated in the same way around the circle. So if you have a table of people and you look at it from a slightly different angle, so the 1 is there instead of there, but the arrangement of people in that table is still exactly the same. And that's what we have when we arrange people around a table, is that when you have something in a straight line that would be different, such as this and this, when you put it together, so put 3 and 4 together, you get this whole 1, 2, 3, 4, 5, 1 in a circle is exactly the same. If there's 5 people around a table, there will actually be 5 of these arrangements that's going to be identical. Yeah? And if there's 8 people around a table, there'll be 8 of these arrangements that's identical. And that holds true for no matter how many number of people arranged in a circle. If that's true, then how do we work out how many arrangements there are? Well, then we have 5 factorial, so if it was just in a straight line, but divided by 5, so just dividing it by the number of arrangements that are identical, yeah? Now, we can actually write 5 factorial as 5 times 4 times 3 times 2 times 1. Cancel the 5s, and this is the same as 4 factorial. So for the answer here, it's just going to be 4 factorial. Now from this, because I said it doesn't matter if you have 5 people in a table or 10 people in a table, it always works. So therefore we can come up with like a general rule, and the general rule that we've came up with is that n factorial divided by n ways is arrangements for n elements around a circle. So that's just your algebraic way of saying that when you have people or things arranged in a circle, you have that number of objects factorial divided by the same number, because that's the number of repeats. Sometimes, so let's consider our n factorial divided by n. So in that case, sometimes you'll see your teachers write n minus 1 factorial for circles. And that's because you can see when we have 5 factorial divided by 5, so n factorial divided by n, when you solve it like this, it actually becomes 4 factorial, so n minus 1 factorial. So if you see this, just know that it's derived from this general equation here, okay? Because this is the proper way to explain why this is, yeah? So just understand that when we're arranging people or things around a circle, it's intrinsically different from a straight line because there's going to be repeats, yeah? Things that are different in a straight line, when you join them together to be a circle, they're going to be exactly the same. And if there's 5 people, there'll be 5 arrangements that are exactly the same. So we divide by 5, okay? All right, now as always with our factorial questions and permutations and combinations, best way to learn them is by doing questions. So let's have a look at question 22 here. So here we have 9 different students arranged around a round table. So let's just say for your formal. And how many different ways can they be arranged around a table? So consider there'll be 9 students. So there'll be 9 factorial if they were standing in a line together. But because we're putting it together in a circle, there's going to be 9 repeats, so 9 identical tables. So that's why we divide it by 9 here, which is actually the same as 8 factorial, which is 40,320 ways of arranging people around a round table, which is actually quite a lot of ways when you think about it. What about if two students need to sit together. So let's say there's two people who are best friends and they want to sit together. How do we work that out? Well, how do we work out those before? If two people need to be together, exactly, we group them together. So we just group the two students together. If we group those two students together and we count them as one, instead of there being 9 different student groups, essentially, there's going to be 8 of them, yeah, because we're considering them as one. So that means I'm going to have 8 factorial. So put the two particular students in a group, so there'll be 8 elements, so 8 factorial. But now they're in a circle, so we're going to have to divide by 8, the number of identical elements. So there's 8 groups, so we divide by 8. Now be really careful not to divide by 9, because we're grouping those two students together. So there's only 8 groups, so then that's why we have 8 factorial divided by 8. Just remember, when we group things together, unless it specifies one person is behind another or one person has to sit to the left of another, those two students, say A and B, can be AB or BA. So they can change. So that's why we can multiply it by 2 factorial. So what we have here is 8 factorial because we group them, divided by 8 because it's a circle, so there's 8 repeats, multiplied by 2 factorial because those two people that are grouped together can change positions. And that's how we get that solution there. And you can just put that in your calculator. So that just becomes 7 factorial times 2. And that gives you 10,080 ways. All right? So if coming straight to that becomes confusing, just start off with thinking it's 8 factorial. Now it's a circle, so I divide by 8. But because I group them together, I need to multiply by 2. So just work through it slowly, through all the different elements, and you should be okay with that. And always remember, if you're grouping people together, always consider the arrangements within that group. Now, we come to the questions with necklaces. Now, necklaces and bracelets in your questions have a very special way of arranging themselves. And that's because when you consider a necklace, right? And let's just say they're beaded necklaces, yeah? So I have these 5 beads here. This necklace is exactly the same as that, because with a necklace, you can just flip it around, yeah? So wearing this necklace is exactly the same as that. That's just flipped around, okay? But this doesn't apply to people because basically you can't flip a whole table around, yeah? You can't flip people around. If you have this, and then 2 is sitting on this side of one and 2 is sitting on the other side. So that would be different for people, but only for necklaces and bracelets where you can actually just flip them around are they the same. Now, so if you think to yourself, if these two arrangements are exactly the same, and that means throughout there's going to be all these 2 arrangements that would have been different if they were people, but now they're the same for necklaces, what do you think you need to do? That's exactly right. Just multiply by half or divide by 2, whichever way you consider it, because they're exactly identical. So there's just going to be half the number of arrangements that there would have been previously. Okay? So in this case, we have 5 factorial, but divided by 5 because it's around a circle. So there's 5 identical ways. But because there's actually necklace, so we can flip it around, we just multiply by half. Yeah, so there's just half the number of ways. So in this case, there's only 12 ways that 5 beads can be arranged around to make a necklace.